Hello everyone. Today we are going to learn about shear force and bending moment diagram. Here we can see that this is a two-dimensional beam ABC. Here one concentrated load 10 kg is acted on this beam, and here in the left support it is a hinge support, and in the right it is a roller support. So we can see that a 10 kg force is acted on this beam, and it is acted on the middle of the beam, middle of the span, and the span length is 10 feet. So first of all we have to determine the reaction forces, because after getting the reaction forces we can easily determine the shear force diagram. This is the shear force diagram, SFD. We call it shear force diagram, and after knowing the shear force diagram we can easily get the bending moment diagram. So shear force diagram and bending moment diagram is necessary because to design a beam or to design a column in a single story or multi-story building, we have to determine shear force and bending moment diagram to determine the absolute maximum shear force and bending moment. So it is very necessary because our beam and column needs to resist the maximum shear force and bending moment diagram. So first of all, we have to determine the reactions of the two supports. One is hinge support and one is roller support. To determine the reaction of the hinge support of point A, we have to know the three equilibrium equations, and the equilibrium equations are summation of fx is equal to 0, and second one is summation of fy is equal to 0, and the third one is summation of moment is equal to 0. So here only two unknowns are given, and in this support only one unknown is given. So to know this horizontal unknown, we have write the summation of fx is equal to 0, and from this equation we easily determine the ax component, and we can determine the ax is equal to 0. But to draw shear force diagram we do not need this ax, because x is the horizontal shear force. We only need the vertical forces to draw this shear force diagram. Okay, so to know about these vertical forces ay and cy, we can write the summation of fy is equal to 0, and in this equation we can easily put the upper forces positive and lower forces negative. So after writing ay plus cy, because these two forces are acting upward, so we write the positive sign before these two forces, and the given 10 kg forces are acting downward, so we write the negative sign before 10 kg force. So after writing this equation equal to 0, because summation of fy is equal to 0. After writing this equation, we can easily write a equation which has two unknowns. One is ay and another is cy. To determine these two unknowns ay and cy, we need to know another equation which is summation of moment is equal to 0, and we have to determine these two forces by this equation. So if we can take moment at point A, which is summation of moment is equal to A at point A is equal to 0, we can write each summation of moment at point A is equal to 0. and take clockwise is positive. So if we write this equation, which is 10 into 5, which is with respect to A, it is a clockwise direction, and CY is acting upwards, so it is anti-clockwise direction with respect to point A. So if we write the moment equilibrium equation, which is 10 into 5, because force into distance, moment is equal to force into distance. So if we take moment at point A, then EY and XY doesn't give any moment, because at point A these forces are acting on this point. So only 10 kick force and CY force are given to take part this moment. So if we write this equation, we can easily determine the CY force, which is 5T, and from equation 1 we can easily put the value of CY and we can get the value of AY. So after knowing these unknown forces AX, AY and CY, we can easily draw the shear force diagram. So before draw the shear force diagram, there are two methods. One is integration method and another is section method. Here we draw shear force and bending moment diagram by integration method. Here integration method is used to draw the shear force and bending moment diagram. The integration method named another which is graphical method. So to know this method how it works, we have to know the order of lines. What is the order of lines? Order of lines means if we here comes first the concentrated load, then the straight line, then slope, then parabolic, then cubic. What does this means? If we integrate some straight line means if y is equal to 5 is a straight line, isn't it? Y is equal to 5 is a straight line. If we integrate the straight line, if we integrate the 5, we can get the 5x, which is a sloped line, isn't it? And if we integrate the 5x, we can get 5x square by 2, which is a parabolic line. If we then again integrate the 5x square by 2, we can get x cubed by 6, 5x cubed by 6, which is a cubic line. So in integration method, if we integrate this, we can get the straight line. If we integrate straight line, we can get the slope. If we integrate the slope line, we can get the parabolic, and after at last we can, if we integrate the parabolic line, we can easily get the cubic line. So it is the shortcut method of this integration or graphical method. So to draw this shear force diagram, we need to know this order of the lines. Okay, if the problem is given the concentrated load, then the shear force diagram will be look like straight line, and so on. If the shear problem is straight load or line, then the shear force diagram look like sloped line. So to draw the shear force line, we have see the here in the problem we see that is a 10 kick force, which is a concentrated perpendicular load. So our shear force diagram will be straight line. So from left we can draw the shear force diagram, which is 5 kick upward. Then we go straight, and then 10 kick downward, which is my plus 5 minus 10 is equal to minus 5, and then straight line, and then here at point C, Cy is 5 kick, which we can determine here, and 5 kick upward. So at point C, it goes up and becomes 0 kick. So it is easy to determine the shear force diagram. After that, we can determine the bending moment diagram, which is nothing but a summation of shear force diagram area, which means area is equal to height into width. Here in this shear force diagram, we see that height is the 5 feet and width is the 5 feet, which is written in here. So height is 5 feet and into width is 5 feet. Here the result is 25 feet. So the result is 25 feet. Here in this diagram, we can see the shear force is a straight line. So if the shear force is a straight line, the bending moment, the next bending moment diagram is also a sloped line. So the bending moment increases from point 0 and it is a sloped line, which results in 25 feet. We can easily determine the absolute maximum shear force, which is in this graph we can see that plus 5 or minus 5, whatever it is. We can neglect the sign, but we can take the value, which is absolute value. Absolute maximum shear force is 5 kg and absolute maximum moment. In this graph, we can see that 25 feet is the absolute maximum moment. After knowing this absolute maximum shear force and absolute maximum moment, we can design a beam or a column in a building. Thank you all for watching this video. I hope everyone can understand my lecture video. Thank you all. Thank you.